on. So here are some more theorems. Now we have basically if a right triangle is inscribed, you guys need to make sure you get these down. If you have a right triangle that is inscribed in a circle, then the hypotenuse is the diameter of the circle. That's the first thing. So if I have a right triangle inside a circle, hypotenuse is automatically the diameter. Then we can also say that if one side of the inscribed triangle is the diameter of the circle, then you have a right triangle. So it works both directions. And the angle opposite the diameter will always be the right angle. So the diameter is the one that goes to the center, so B is the right angle. So if angle B is a right angle, or angle B is a right angle if and only if AC is the diameter of the circle. And that's really what this theorem's saying. So there's two ways to get a right triangle in there. One, it could be a right triangle, therefore you have a diameter. Or if you have a diameter and a triangle is drawn on that half, then it has to be a right angle. Now this should make sense to you, because what do we know about the intercepted arc? Well, this is ABC is an inscribed angle, and since ABC is an inscribed angle, it is half the measure of the intercepted arc. Well, the arc is AC, and you can see that it is a semicircle which has a measure of 180 degrees. So that should make sense to you in that case. So then this next one, I thought I could move it so you could see that drawing a little bit better. If you have a quadrilateral inscribed inside inside a circle, then the opposite angles are supplementary. So we know that if we add together D and F, those two angles, if they're supplementary, well, we should all know supplementary by now is 180, and EG should be 180 degrees. And that should make sense, because if you look at where these points are, if I'm talking about angle D is half the measure of this part of the circle, and angle F is the other half, combined together, they should add up to be 180, because all the way around is 360 degrees. You're using up 360 degrees to go from E to D to G, and from G, F, E is 360. So this angle here, if it happened to be 180 across up the top, the other half would be 180. Both of these angles would be 90 degrees. So think about that a little bit and get this down. So we're moving on to example 6, and we're going to find the value of the variables in this one. And you may notice that we have a quadrilateral inscribed, and so we have to remember the previous theorem. And the previous theorem said that the opposite angles are supplementary. So angle X plus 82 has to equal 180. Likewise, angle Y plus 68 has to equal 180. That's the previous theorem, and it said that if you have a quadrilateral inscribed inside a circle, opposite angles are automatically supplementary. So now it's just a matter of solving our steps of algebra. So if I subtract 82 on this one, and I'm going to do both of these at the same time because I'm going to do the same steps, and then I end up with this one, x is equal to 98, and over here, y would be equal to 112. Which should make sense now. If I was to add 68 and 112 together, I should get 180. If I add 82 and 98 together, I should get 180. And that's really all we're trying to do for this one. And so then we have example 7 here. And it says find the value of each variable. This time we want c and x. This looks a little bit more challenging because you notice we have two x's and we have two c's. But what do we know about opposite angles in the opposite angles of a quadrilateral inscribed inside a circle? Well, that theorem that we just learned said opposite angles are supplementary to one another. So that would mean that c is going to have to equal, or c plus 2c minus 6 equals 180. They're supplementary. That would also mean that 8x plus 10x would equal 180. They're supplementary to one another. So solving these algebraically, this one I'm combining like terms, which gives me 18x equals 180. And if I then divide by 18 to solve for x, which is one of the things we need to find, x itself will equal 10. And that's really all we wanted. We'll plug them back in to check in just a second. The next one, we got to combine like terms. And when I combine like terms, I end up with 3c minus 6 equals 180. If I now add 6 across the equal sign, I'm left with 3c equals 186, and then if I divide by 3, my c value in this case will be 62. And so I can check these by plugging them in. If I plug in 10 into 8 here, 10 times 8x, that one I will get 80. So that angle is 80 in there. If I put 10 in for x, I get 100. You can see opposite angles right there are supplementary. So that worked out. I did that one right. If I do the same with the 62, well, c is 62. That's nice. If I plug in this one over here, we should get, well, 2 times 62 minus 6. And you'll notice that first thing I'm going to do is that I'm going to multiply 2 times 62, and 2 times 62 is going to be 124 minus 6. If I subtract 6 from that, I believe I'll get 118 for that angle. And so that angle right there is 118. If I add 118 and 62 together, again, 180. So that's the way all of these work, and you can check your answers if you like as you go through these. Alright, so then we're at the out, and it says, again, we're trying to find x and y. Well, a couple things that we know. We have inscribed angles here. And so for our inscribed angles, we have the opposite. This arc AB is going to be double the measure of x. And likewise for y. Well, I'm going to go with the easy one first, the one that I think is easier. I don't necessarily know it's easier or not. But the one that's I already have the inscribed angle and the arc. And so the arc is 84, and I know by my theorem that if I cut 84 in half, I have 42. That's the measure of angle y. Then, for this one, since I don't know the arc opposite angle x, but I could find it because, look, I've got a diameter here. So you got to kind of think through these. And if I have the diameter, that means that DAB arc is 180 degrees. If it's 180 degrees, that means this angle up here should be 96 to make 180 degrees, 84 and 96. Well, if I add these two guys together, if I cut 96 and I get my 180. If I cut this guy in half, I believe I get 48 would be the measure of angle x. And so let's see, it says multiple choice if needed. It's not letting me do it, so whatever. So I guess the choice would be 48 and 42, which happens to be B in this case. So well, I hope you guys have enjoyed this webinar. Sorry for all the little mistakes I made along the way. I will be recording another one very soon. Thank you.